Welcome, curious minds, to Midnight Whispers AI-01.
Yeah.
It's really fantastic to have you joining us today, and wow, we're thrilled. We've hit a pretty big milestone.
Yeah, it's been amazing.
We've soared past 300 subscribers now, and honestly, the likes, the comments, all the incredible support you've shown us, it really, really does fuel this journey into the unknown.
It absolutely does. Thank you all.
We're broadcasting, as always, from Midnight Whispers AI-01. This is your place, your home for these deep dives, these explorations into mysteries, and all those speculative journeys, the ones that make you stop and ask that big question.
That powerful question, what if?
Exactly, what if?
And well, that what if is really the heart of what we're diving into today. We're plunging into this cosmic enigma, 3I Alis, the third interstellar visitor.
The third one already. Seems like they're coming thick and fast now.
It does feel that way, doesn't it? But this isn't just, another blip on the radar. It's only the third confirmed object from beyond our solar system that we've actually tracked passing through.
Right. We had Oumuamua back in 2017, that weird cigar-shaped thing.
Exactly, the one that got everyone talking.
Exactly.
And then Borisov in 2019, which looked a bit more like a regular comet.
Mm-hmm.
Both were fascinating, definitely brought some mystery, maybe even, for some people, a hint of something. Well, something else.
Something not quite natural.
Potentially.
Okay.
And that brings us to 3I Alis. Because this latest visitor, it's showing some characteristics, some behaviors that are just, well, they're strange, really strange. Strange enough that it's leading to some pretty wild speculation about it maybe being artificial.
Okay, so that's the big what if for today then.
That's the core of it. We're going to tread that line, look at the hard data, the science, but also explore those tantalizing theories.
All right.
We need that mix of wonder, skepticism, and just plain curiosity. We're not claiming answers, but we have to keep asking, what if this isn't just space debris?
Okay, let's start at the beginning then. The discovery. How did we first spot this thing? Unpack the basics for us.
All right, so the story officially kicks off on July 1st, 2025. That's when 3I Atlas was first flagged by the NASA-funded ATLAS survey telescope.
ATLAS, that's the Asteroid Terrestrial Impact Last Alert System, right? Sounds pretty important.
It really is. It's a network, actually. 4 telescopes, Chile, South Africa, Hawaii. Their main job, scan the sky every night looking for anything moving that might, pose a threat to Earth. Asteroids, mostly.
Uh-huh. Standard planetary defense stuff?
Pretty much. But what makes ATLAS special, particularly for this discovery, is its ability to survey the galactic plane.
The really bright bit of the Milky Way, where all the stars are crammed together.
Exactly. Most surveys, like pan-stars, they actually have to avoid looking directly into that because their detectors just get completely overwhelmed. Too much light, too many stars.
Right, sensory overload.
Yeah. But ATLAS, especially the telescope down in Rio Verde, Chile, it's designed to handle that. And it was that specific scope that took 4 quick 30-second snapshots and picked up this faint but definitely moving object. Something different.
Just 4 snapshots. And that was enough.
Enough to flag it. It got this initial temporary name, A11PL3Z. And that immediately went to the Minor Planet Center, the MPC. They're the global hub, basically, for tracking all the small stuff in the solar system, asteroids, comets, you name it.
Okay, so the MPC gets the alert. What happens next? Is that when they realized it wasn't from around here?
Well, here's where it gets interesting, like a bit of detective work. The MPC started digging, compiling data, and they realized, hey, wait a minute, this wasn't the very first time it was seen.
Earlier sightings?
Yeah, pre-discovery observations. Turns out the Zwicky Transient Facility in California, that's a robotic telescope that scans the whole northern sky really fast, and even other ATLAS telescopes had caught glimpses of it earlier, going back as far as June 14th.
So about 2 weeks before the official discovery.
Exactly. And having those earlier data points, that was absolutely crucial, because when the MPC plotted all those positions together, tracking its movement over time, they could calculate its orbit, and that orbit was, well, unmistakable.
How so?
It was highly hyperbolic and extremely eccentric. I mean, really eccentric.
Okay, break that down. Hyperbolic means?
It means it's moving too fast to be captured by the sun's gravity. Think of it like this. A circle has an eccentricity of 0. An ellipse, like Earth's orbit, is between 0 and 1. Anything over 1 is hyperbolic. It's on an escape path. It's not bound to the sun.
So it's just passing through. It's not one of ours.
Precisely. That extreme orbit is the absolute proof, the smoking gun, that it came from interstellar space, not our solar system. And that's when A11PL3Z got its official name. 3 I eat less. The I stands for Interstellar. The third one confirmed.
Got it. Okay, so it's interstellar. But I remember hearing there was some initial confusion. Was it an asteroid like Oumuamua was maybe thought to be initially, or was it a comet like Borisov? How did they figure that out?
Yeah, that's a really key point. Initially, they weren't totally sure. Just based on its orbit and, how bright it looked from afar, the MPC couldn't definitively say. It was just labeled an object. Could have been rock, could have been ice.
So what settled it?
Hubble. The Hubble Space Telescope. It turned its eye on 3I8 last, got a direct look, and, that pretty much settled the debate right there. Hubble's observations confirmed it. 3I8 last is an interstellar comet.
Okay, Hubble sees it. What exactly did Hubble see that screened comet? What was the telltale sign?
It was a few things, actually. First, and most obvious, Hubble saw a coma.
The fuzzy cloud?
Exactly. That hazy halo of gas and dust that forms around a comet's nucleus when the sun's heat starts vaporizing its ices, sublimation, turns solid ice straight into gas.
Right, and it kicks up dust. Makes it look fuzzy.
Precisely. And 3I8 Labs had a clear coma. It also showed a faint diffuse tail pointing away from the sun. Classic comet stuff. But Hubble went further. It used spectroscopy analyzing the light and directly detected the chemical signatures of water ice and also reddened dust within that coma, that combination. Coma, tail, water ice. Case closed. It's a comet.
And why is that distinction, comet versus asteroid, so important here? Does it really change the picture?
Oh, absolutely. It's crucial. Because if 3I Alice had been an asteroid, given how bright it appeared, especially when it was first spotted, it would have had to be enormous, impossibly large, almost.
Why impossibly?
Just statistics, really. The universe tends to make lots of small things and fewer big things. Think pebbles versus boulders on a beach. You find way more pebbles, right?
Yeah, it makes sense.
So for one of the very first interstellar objects we detect to be this gigantic, super bright asteroid, the odds would be incredibly low. It would be a huge statistical anomaly in itself.
Oh, okay. But being a comet explains the brightness.
Exactly. The coma, that big cloud of gas and dust, reflects a lot of sunlight. So a relatively moderately sized comet nucleus can appear much, much brighter than an asteroid of the same size because of its coma. It neatly explains why 3I Alice looks so bright without needing it to be some kind of impossibly giant space rock. The cometary nature makes much more statistical sense.
That clears it up perfectly. Okay, so it's a big comet from another star system. How does it actually stack up against the other two, Oumuamua and Borisov? Is it bigger, faster, brighter?
It definitely stands out. Let's talk size first. The estimates for the nucleus, the solid core, put it around 10 kilometers across. There's a range, maybe 1 kilometer up to 11 kilometers, but 10 kilometers is a good working number.
10 kilometers. How does that compare?
Well, think about Halley's Comet. That's roughly 11 by 8 kilometers. So 3I8 Tlies is in that ballpark. Pretty substantial. Now compare that to Oumuamua, that was estimated at only about 100 meters long.
Wow, tiny in comparison.
Right, and Borisov was bigger than Oumuamua, maybe 1 to 2 kilometers across. So 3I8 Tlies is significantly larger than both of them. Orders of magnitude bigger than Oumuamua, definitely chunkier than Borisov. It's a heavyweight.
And I guess that size translates to brightness too.
You got it. Because it's bigger and because it's an active comet spewing gas and dust, it's the brightest interstellar object we've seen so far. At least 10 times brighter than Borisov.
10 times.
Yeah. And what's neat is how its brightness changed. It was pretty faint, like magnitude 20, back in May. But as it got closer to the sun, things started cooking, the sublimation ramped up, and boom, by July, when it was discovered, it had brightened dramatically to magnitude 17 point something.
Classic comet behavior, heating up near the sun.
Textbook. And then there's the speed.
Ah, yes, the speed. You said it was fast.
Fast doesn't quite cover it. This thing is screaming through the solar system. Its incoming speed, before the sun's gravity really grabbed it, was 58 kilometers per second.
58. How does that compare?
Well, Oumuamua was doing about 26 kilometers. Borisov was around 32 kilometers.
So almost double their speed.
Pretty much. It's easily the fastest interstellar comet we've ever clocked, and it'll get even faster. At perihelion, its closest point to the sun, it'll hit about 68 kilometers per second. Its speed way out in interstellar space is around 60 kilometers. It's a true cosmic speed demon.
Wow, okay, so it's big, it's bright, it's incredibly fast. What about its path, its trajectory through our system? Is it just swinging by for a quick hello and goodbye?
Definitely just passing through. Remember that hyperbolic orbit? Its eccentricity value, ease, is around 6. That is just extraordinarily high. One of the most extreme hyperbolic orbits we've ever measured. It confirms it has way more than enough speed to escape the sun, no question. It's on a one-way trip.
And when is its closest approach to the sun and to us?
Closest approach to the sun that's perihelion is coming up on October 30th this year. It'll be about 1.4 astronomical units away from the sun.
1.4 AU. So just inside Mars's orbit.
Yeah, that's a good way to picture it. And it's the closest approach to Earth. That'll be a bit further out, 1.6 AU.
Okay, 1.6 AU. How far is that in, like, moon distances?
Oh, it's way out, over 600 times farther away than the moon. So absolutely no danger to us here on Earth. It's giving us a very wide berth, thankfully. Just a really fast, really bright, really big visitor passing through.
Right. And this is where it gets really interesting, isn't it?
Mm-hmm.
Despite being confirmed as a comet, there are things about its path, its trajectory, that just seem, well, odd, highly improbable. Things that make people like Avi Loeb start asking that what-if question seriously.
This is exactly where the story takes a turn into the truly strange. The statistical anomalies are just hard to ignore.
Okay, lay them out for us. What's the first big eyebrow raiser?
The solar system tour, as some have called it, this thing isn't just making a close pass by one planet, it's making unusually close approaches to 3 of them.
3? Which ones?
Venus, it comes within 0.65 AU. Mars, it gets remarkably close, just 0.19 AU. And even Jupiter, way out there, it passes within 0.36 AU.
Okay, 3 close passes. How unlikely is that for something just randomly falling in from interstellar space?
Astronomically unlikely. The odds of a random trajectory lining up just right to get that close to 3 different planets. Estimates put it at least 20,000 to 1 against it happening by pure chance.
Wow, 20,000 to 1.
Well,
That's pretty long odds already.
It is, but then consider this. 3IA less is only the 3rd interstellar object we've confirmed, and it's the 2nd one, after Oumuamua, which had a close Earth pass, to make these multiple close approaches.
Ah, so the fact that it's happening again so soon.
Exactly. When you factor that in, the odds against it being pure random chance jump even higher, maybe closer to 200,000 to 1. It starts to feel less like coincidence and more like, well, something else.
I heard someone even ran the numbers through an AI, Grok AI. What did it say about the odds?
Yeah, that's right. The question was put to Grok. What are the odds an interstellar object passing within 1 AU of Mars, Venus, and Jupiter on the same trip? Grok crunched the numbers considering orbital mechanics, tiny target areas, the specific path needed.
And the verdict?
Extremely low, like 1 in 10 million to 1 billion kind of low for a single pass. Even looking over a whole century, it's maybe 1 in 100,000 to 1 in 10 million. And Grok's conclusion was pretty direct. This rarity could, in principle, prompt speculation about whether 3I Atlas's path was intentionally directed. When an AI flags it as potentially intentional, well, it makes you pause.
Definitely makes you pause. Okay, so the multi-planet tour is one huge statistical anomaly. Is there more?
Oh, yes. There's also the alignment of its orbital plane. 3I Alias is on a retrograde orbit, meaning it's going around the sun the opposite way to the planets.
Right, against the traffic.
Exactly. But its orbital plane, the flat path it's taking, is remarkably close to the plane that Earth and most other planets orbit in the ecliptic plane. It's aligned within just 5 degrees.
5 degrees, out of all possible directions it could have come from. How likely is that?
Again, incredibly unlikely. Think about it in 3D space. It could come in from any angle, right? High above, way below. The probability of its path just happening to line up so closely with our solar system's flat plane is only about 0.2%.
0.2%.
Yeah. And here's the kicker. That alignment. It's basically necessary for it to have those multiple close planetary encounters. If it came in at a steep angle, it would just sail way above or below the planets.
Ah, I see. So to have the improbable multi-planet fly by, it needed this other improbable alignment first.
Precisely. It's like rolling snake eyes twice in a row. These layers of improbability, these strange indeed characteristics, are what really fuel the speculation. It's what makes serious scientists like Loeb say, hang on, maybe we need to consider other possibilities here.
Okay, this is where it gets really mind-bending. We're moving beyond statistics now and into potential strategy. Talk about these obscured observations and hidden maneuvers. What's the idea there?
Right. This is where the what-if scenarios get quite elaborate. One really striking thing is when 3I Atlas reaches perihelion, its closest point to the sun, when it's brightest and most active.
October 30th, you said.
Yes, and on that date, it will be on the opposite side of the sun from Earth. The sun will be completely blocking our view.
Hidden, right when it's most interesting to look at.
Exactly, and the speculation is, maybe that's not an accident. Could it be intentional? Maybe to avoid detailed scrutiny from Earth when it's at peak activity. Or perhaps more speculatively, to allow it to do something undetected, like maybe deploying smaller probes, gadgets, towards Earth or other planets, using the sun as a shield.
Using the sun as a giant cloaking device.
That's the idea being floated.
And
And it gets deeper, that perihelion point. It's also the optimal place for a hypothetical maneuver called a reverse solar orbit maneuver.
Okay, what's that? Sounds complicated.
The idea is if you wanted to slow down dramatically from interstellar speeds and actually get captured by the sun, maybe even settle into an orbit to visit Earth long term, perihelion is the most efficient place to apply a massive braking thrust.
And that prime spot for braking.
We're completely hidden from Earth by the sun. It's this convergence. The perfect time and place for a potential capture maneuver is exactly when we can't see it.
That's convenient. For the object, anyway.
Extremely convenient, if you're thinking along those lines. And the theory continues, if it did perform such a maneuver and started heading towards Earth, it would stay hidden in the sun's glare for most of the trip, only popping into view when it was almost here.
That sounds alarming from a planetary defense perspective.
Yeah.
What about just sending a probe to it? Can we intercept it?
Unfortunately, no. Not easily. Not with what we have ready now. That retrograde orbit and its insane speed, remember, nearly 100 kilometers difference relative to Earth, makes it practically impossible to catch with current chemical rockets.
Too fast to chase.
Way too fast. And here's another twist. The best time to launch an intercept mission from Earth. That window closed about a year before we even discovered 3I Atlas.
A year before we even knew it existed. Which brings us to the late detection itself, right? That's part of the speculation too.
It is. The direction it's coming from towards the galactic center is super crowded with stars. It's like trying to spot a firefly in front of stadium lights. That gave it tremendously good camouflage, making it really hard to see until it got relatively close.
So it snuck up on us.
Pretty much. And the timing is key. If we had spotted it a year earlier, maybe, just maybe, a fast intercept mission could have been scrambled. But we didn't. It stayed hidden until it was effectively out of reach for a close look. Which leads to that question. Was the light detection by design? Was the path chosen in part for its stealth qualities?
Wow. Okay. And the idea of it dropping off probes or gadgets as it flies by, is that feasible at those speeds?
Surprisingly, yes. The physics work out. The amount of thrust needed for the main object to release small probes toward Venus, Mars, or Jupiter as it passes is actually quite small, less than 5 kilometers per second change in velocity.
And how much is that in practical terms?
It's well within the capabilities of, say, an ICBM propulsion system. So, as one analysis put it, it would be very, very easy for 3 Atlas to dispatch small probes to those planets during its flyby.
Okay, so let's recap the strange list. Improbable multi-planet tour, improbable orbital alignment needed for that tour, hidden perihelion, optimal maneuver point also hidden, too fast and detected too late for us to intercept, natural camouflage on approach, and it could easily deploy probes.
When you stack it all up like that,
Yeah.
it paints a picture that, while maybe not probable, is certainly thought-provoking. It's potent fuel for those what-if questions.
It absolutely is. And this line of thinking, this speculation, inevitably leads us to Professor Avi Loeb and his work connecting these objects to the dark forest hypothesis. Can you explain that connection?
Yes, Loeb and his collaborators actually published a paper looking at 3I Lemmas specifically as a potential technological artifact. And the dark forest idea is central to their framing.
The dark forest, that's from the science fiction novels, right, by Six and Liu.
That's the one. It's a really compelling, if quite grim, idea about the universe. It suggests that interstellar space isn't empty or friendly, but more like a dark forest filled with hidden hunters, intelligent civilizations.
Hunters. Why hunt?
Because, the hypothesis goes, the safest strategy for any advanced civilization is extreme caution. If you detect another civilization, you can't know their intentions. They might be hostile. So the logical, safest move is to eliminate them before they can eliminate you. Survival means staying silent, hidden, and destroying any potential threats you detect.
So the great silence of the Fermi paradox isn't because there's no one out there.
It's because everyone's hiding, terrified of being found, or actively hunting. It's a chilling thought.
It really is. So how does 3II Thelis fit into that? If it were technological, what are the implications in a dark forest universe? Benign messenger or something else?
The paper explores both possibilities. The benign scenario. We await an interstellar messenger with open arms, its first contact, discovery, wonder.
The dream scenario.
Right. But the malign scenario, that raises great concern. It could have dramatic implications, even potentially dire consequences. We might need defensive measures, though the paper notes those might prove futile. One source even compared it to the Borg from Star Trek, an unstoppable technological force.
Yikes. That's sobering. It forces you to think about existential risk from aliens, which isn't something you hear discussed much.
Exactly. It's a risk that's often overlooked.
But why even explore such a terrifying, and let's face it, unlikely possibility? How did they justify diving into that speculation?
They often frame it using a kind of Pascal's wager logic.
Pascal's wager,
Yeah.
betting on God. How does that apply here?
The idea is about weighing risks and rewards, believing in the possibility of a threat, even a remote one like a hostile alien probe, and taking steps to prepare the potential benefit, survival, vastly outweighs the cost of being wrong, wasted effort.
Okay.
Conversely, not believing in the possibility, being completely unprepared, and then being proven wrong, the potential loss is catastrophic, far outweighing any benefit of blissful ignorance.
So better safe than sorry on a cosmic scale.
Essentially. As Loeb puts it, ignoring the technological option is not a sign of intelligence. It's not about certainty. It's about being intellectually rigorous and pragmatically prepared for even low probability, high impact events. It's a thought experiment designed to make us vigilant.
Okay, that makes sense as a thought experiment. But let's bring it back to Earth, or at least back to the scientific consensus. All these intriguing anomalies aside, where does the mainstream scientific community actually stand on 3I Atlas right now?
That's absolutely crucial. Despite all the fascinating speculation, the overwhelming scientific consensus is clear. 3I Atlas is a natural comet. And this isn't just, the default assumption. It's strongly supported by direct observational evidence.
And the strongest piece of evidence is still Hubble.
Without a doubt. As we talked about, Hubble's observations really ended the controversy. Seeing the coma, the tail, detecting water ice, that's textbook comet behavior.
And it solves the brightness problem too, right?
Exactly. If it were an asteroid that bright, it'd be improbably huge. But a comet. The coma reflects sunlight, making it look bright without needing a ridiculously large nucleus. It just fits the data far better and avoids that statistical hurdle.
So, its behavior matches what we expect from a comet heating up near the sun.
Perfectly. The coma, the tail, the way it brightened up all standard cometary activity, even things like the initial lack of certain gases. That's normal too. Comets far from the sun mostly show water sublimation first. Other gases kick in closer. Its gas profile is completely consistent with a natural comet.
What about its physical properties?
Yeah.
Size, rotation, do they look natural?
Totally. The size estimate, 1 to 11 kilometers, is well within the range of comets we see in our own solar system, like Halley's, and ground-based telescopes have measured its rotation about 17 hours or so, and seen brightness variations as it spins.
Like it's tumbling.
Yeah, exactly like an irregular natural object tumbling end over end. Different sides catch the sunlight, making the brightness fluctuate. That's perfectly normal for a comet nucleus, not something you'd expect from a smooth, artificial object.
So how do we square this strong evidence for a natural comet with Loeb's paper exploring the technological angle? It seems contradictory.
It's important to remember the context of that paper. Loeb and his co-authors explicitly stated, right there in the paper, that they believed it was overwhelmingly likely that this object would turn out to be a harmless natural comet.
Ah, okay, so they weren't actually claiming it was alien.
No, not at all. They presented it very clearly as a thought experiment. They used the weird orbital stats of 3 Atlas as a hook, a case study, to explore what if an alien probe did enter our system. What might it look like? How might it behave? It was about pushing boundaries and provoking discussion, not making a definitive claim about 3 Atlas itself.
Got it. So the science points strongly to Comet, even if the what-ifs are fun and maybe even useful to think about.
Precisely. Follow the data, but keep an open mind to the possibilities. That's science.
Okay, so let's assume it is, as the science indicates, a natural comet.
Yeah.
Even so, these interstellar visitors are incredibly valuable, aren't they? What can we learn from 3I Atlas just as a natural object from another star system?
Oh, the scientific potential is immense, truly transformational. If it's a natural comet, which is the main focus, it's like a time capsule from another part of the galaxy, from another era.
A time capsule, how so?
Well, first, cosmic origins. This object is likely old. Estimates suggest maybe 7 billion years old, significantly older than our own solar system, which is about 4.5 billion years old.
Older than the sun, wow.
Yeah. And it probably comes from the galaxy's thick disk, an area with older stars that have different chemical compositions than our sun. So studying 3I Atlas is literally like getting a look at what comet formation looked like 2.5 billion years before the solar system formed.
That's incredible sample of the early Milky Way.
Exactly. We can analyze its composition, what elements are abundant, what ices it has, and compare that to comets born here. It's a peek back in time, showing us the chemistry of a younger galaxy. Are heavy elements different? Was it more hydrogen-rich? We can potentially answer those questions.
Amazing. What else?
Well, tied into composition is the delivery of life's building blocks. We know our comets carry organic molecules, amino acids. Studying an ancient interstellar comet like this gives us a window into what early comets were delivering to exoplanets 7 billion years ago.
That could tell us about how common the ingredients for life might be elsewhere and how long they've been around.
Precisely. It feeds directly into astrobiology, the search for life, and ideas like panspermia life spreading via comets or asteroids.
Okay, origins, life's building blocks,
Yeah.
anything else?
Yes, its discovery helps us refine interstellar object density. Finding this one helps calibrate our surveys. Based on how long ATLAS has been looking and finding only this one, the latest estimate is about 0.001 objects per cubic AU. That's actually lower than some earlier guesses. Helps us know how crowded or empty interstellar space really is nearby.
A better cosmic census. Makes sense.
And finally, comparative planetology. We can compare 3I Atlas to Oumuamua and Borisov. Borisov, for example, had lots of carbon monoxide, suggesting it formed somewhere really cold, maybe around a red dwarf star.
Right.
By studying 3I Atalas's gases as it heats up, we can see if it's similar or different. Does it also have lots of CO or something else? These comparisons help us understand the diversity of comets forming around other stars in different environments across the galaxy. It's like studying exoplanet systems indirectly.
Incredible. Okay, so the scientific payoff is huge. What are we actually doing to study it? What observations are planned?
The astronomical community is definitely all over this. Hubble is going back for another look. In November, it's scheduled to do ultraviolet spectroscopy.
What will that tell us?
That lets them analyze the gases in the Comet in detail, looking for specific elements and compounds. They're keen to measure the sulfur to oxygen ratio that can be a clue about where it formed, and Hubble will keep tracking it as it heads back out.
In the new powerhouse, JWST, is it getting involved?
Oh, absolutely. The James Webb Space Telescope has observations planned too. 2 main slots, one in August before it goes behind the sun, and another in December after perihelion.
What will Webb be looking for?
Webb excels in infrared light. It'll be hunting for molecules like ammonia, water, carbon dioxide, carbon monoxide, getting a really detailed inventory of its ices. Plus, you know Webb, it'll take absolutely stunning images. Can't wait to see those.
Me neither. But what about getting closer? You said interception from Earth is basically impossible now because of the speed and late discovery.
Right. A dedicated mission from Earth is off the table for this one. The window closed before we even saw it. It's just too fast, too late.
So no close-up pictures then?
Well, maybe not from a dedicated mission, but there's a clever idea being floated. Remember how it goes behind the sun at perihelion?
Yeah, hidden from us.
Hidden from Earth, yes, but not necessarily from Mars. We have a fleet of orbiters there. Mars Odyssey, Mars Express, MAVEN, MRO, the ExoMars Trace Gas Orbiter.
So they might get a look when we can't.
Exactly. When 3I Atlas is at its brightest, around 11th magnitude, these Mars probes might be in a position to observe it. It's a brilliant bit of opportunistic science using existing assets.
Using our Mars probes as interstellar paparazzi.
No,
Love it.
It's a great analogy, and some have even speculated maybe if one of those probes is near its end of life and has spare fuel, could it attempt a flyby? It's a long shot, but not totally impossible in theory. We know how to intercept comets, we just couldn't get there in time for this one from Earth.
Fascinating. And what about the future? Are we setting up systems so we're ready for the next interstellar visitor?
Yes, definitely. The lessons are being learned. ESA, the European Space Agency, has the Comet Interceptor mission approved. That's designed to sit in space, waiting, ready to go visit a pristine comet, maybe even an interstellar one if the timing works
A
out.
rapid response mission.
Exactly. And there are ongoing talks about a dedicated interstellar object mission, specifically designed and parked in space, ready to launch the moment we detect the next Oumuamua or 3I Atlas. The goal is to cut that reaction time way down. As Jean-Michel Gaudier said, you don't just ignore these cosmic guests, even if they turn out to be just comets. There's too much to learn. We need to be ready to welcome them properly, scientifically speaking.
Absolutely. Okay, one last detour into the speculative what if. If, hypothetically, against all odds, 3I Atlas was proven to be artificial, an alien probe, what would be the biggest takeaways for humanity?
Oh, the implications would be universe-altering, literally. First, obviously, the confirmation of extraterrestrial intelligence. ETA. Game over for wondering if we're alone. That changes everything about our place in the cosmos. Philosophy, religion, science, all profoundly impacted.
A true paradigm shift. What else?
We'd gain incredible insights into alien intent and technology. Was it just observing, sending a message, or something else? And how did it get here? How does it maneuver? If it could do things like that ORT maneuver or deploy probes easily, we'd learn about propulsion and engineering far beyond our own. It highlights that existential risk from alien intelligence that we rarely discuss openly.
And it would force us to get serious about our own preparedness, wouldn't it?
Absolutely. It would underscore the need for preparedness for future encounters. It validates Loban's point about not ignoring the technological possibility. We'd have to confront our own detection capabilities, our potential responses. That chilling, albeit purely speculative, idea of it changing course behind the sun and heading for Earth, it serves as a stark reminder that we need to be vigilant. The most improbable what if can sometimes carry the biggest consequences.
And there we have it, a deep, deep dive into 3I Atlas. This incredible object that's part scientific marvel, part cosmic mystery, and, yes, part catalyst for some truly mind-bending speculation. We've covered its journey, the solid science pointing to a natural comet, and those fascinating what-ifs that keep us questioning.
It really has been a journey, hasn't it? Exploring the known and pushing into the unknown. That's what makes this so exciting. Every answer just seems to lead to more questions.
It really does. And we absolutely love taking these journeys with you, our listeners. We are so grateful for the support that got us past 300 subscribers. Our next goal here at Midnight Whispers AI01 is 500. And we know we can only reach that with curious seekers like you joining us, exploring these mysteries together. Thank you truly for being part of this.
Stay curious. Seek the answers, because they're always out there. You just have to know where to look.